So that leads us to the conservation of mechanical energy, right? So mechanical energy is E total equals kinetic energy plus potential energy. For a conservative system, when no non-conservative forces such as friction is present, the mechanical energy of a system is conserved. So delta E equals 0, delta I equals delta F, and the total change in kinetic plus change in potential equals to 0. So now in this case, let's do an example to understand in more detail what is happening when we talk about conservation of energy. So let's say a cart starts from a position 4, which is up here, and with initial velocity 15 meters per second, and it goes towards the left. Find the speed of the position of the carts when it is at number 3, 2, and then at number 1. And we are going to ignore friction. Since we are now ignoring friction, that means that the total energy of the system should remain constant. Now, how do we solve for these problems? Okay, now let's start at the beginning. So my first step is when my object is at really high points. I'm going to try to copy it as best as I can. And then here, and then it goes down here. So this is my number 4. This is number 3. This is number 2, and this is number 1, which is completely at ground. Okay, this is when we get back to the ground. So this is what the path that my cart follows. So at the top at number 4, when it is at rest, it is at a height, say, 20 meters, right? And at point 3, the question says that its height is 10 meters. And at point 2, the height is 15 meters. And at this point, the height is 0 meters. Okay? Now, how do I approach this problem? I know that there is no friction. So that basically means is delta E will equal 0. And delta E, I know, is a sum of kinetic plus potential equals 0. And kinetic energy is always given by 1/2 mv squared, and potential energy is always given by mgh. Okay, so these are information that I know that I have. I know that to begin with. So at position the difference between position 3 and position 4. Let's look at it. We know that since delta E equals 0, E final should equal E initial. That means kinetic energy final plus potential energy final should equal kinetic energy initial plus kinetic energy, potential energy initial, right? We all know that. Okay, so now let's look at it. What is kinetic energy final? It is going to be 1/2 mv, let's call it 3 squared, plus mgh at 3 equals kinetic energy initial will be 1/2 mv4 squared plus mgh4. Okay? Since m is in each of these terms, I can sort of ignore it and get rid of it. And I'm looking for V3. So now let's start plugging in values. So we have 1/3 squared equals 1/2 mv at position 4 squared. So sorry, I don't have m anymore. So I have 1/2 V4 plus GH4, right, minus GH3. And there's a half here, which basically means is I can multiply this whole side with 2, multiply this side with 2, so get rid of this 2, and I will have V3 squared equals V4 squared plus 2GH4 minus H3. So notice I did a couple of steps in here that you should probably be writing down while you're doing this by yourself. So what was the velocity at point 4? the example tells me that it was 15 meters per second. So I can plug that in here. So it's 15 meters per second squared plus 2. The value of acceleration due to gravity is 9.8 meters per second squared. H4 was 20 meters minus H3 was 10 meters, right? So do a quick calculation, plug it into your calculators, and you should come up with V3, which is equals to 20.5 meters per second. Now, how will I go from point 3 to point 2? Interestingly, you could go through the whole derivation all over again, or you could be smart about it and realize that your answer is going to come very similar to this thing that you have. Okay? I am not going to do this for you, but what I am going to do is going to give you the answers for V2 and V1 and let you guys try to solve it. It's the same process all over again, so I'll let you guys solve it. So the answer to V2 is going to be 18 meters per second, and the answer at V1 will be 24.8 meters per second. The height here at 2 will be 15 meters, and the height here will be 0 meters.